Hello and welcome back. It's late June morning as I'm recording these, and I'm in my office in Beveridge, and the birds outside are just great. I hope you can kind of hear them a little bit in the background if you listen carefully. So this section, section 6.5, is about special products. And what we're going to do is go back and remember a little bit about some of the things, some of the special products that we had in when we were looking at multiplying polynomials. So recall that a plus b times a minus b is equal to a squared minus b squared. So really, if you think about going from here to here, that's factoring. When we go from here to here, we're factoring. When we're going from here to here, we're multiplying. So, for example, suppose I have a really simple problem, like, maybe x squared minus 4y squared, and I want to factor it. Well, that's going to factor, excuse me, x and x, 2y, plus and minus. In other words, it looks very much like this did up here. And in fact, what this is called is the difference of two squares. In other words, if you're trying to factor something of this form, the difference of two squares, it always factors like this: a plus b times a minus b. And that's a nice rule to remember. Difference of two squares. We just have two terms, each is a square, and we're subtracting. Okay? I think it's always important to talk about the sum of two squares, which looks like a squared plus b squared. And it's very important to note that the sum of two squares is prime. It doesn't factor. So it's a trick question, and you just want to be on your toes about that. So let's remember this. Let's do another recall. That something like x plus a squared is equal to x squared plus 2ax plus b squared. And so you want to be on your toes when you're trying to factor something that looks like this. And what you have is something squared, and in the middle you have twice the product of those two terms. So here's a simple example like that. If you have x squared plus 6x plus 9, you can think of it as x squared plus 2 times 3 times x plus 3 squared. And then it fits exactly into this pattern, which means it will factor as x plus 3 squared. The pattern is when you square this, you get x squared. When you square this, you get 9. And if you take these two and multiply and double it, you get 6x. Okay? And this is called a perfect square. Just like 9 is a perfect square, 16 is a perfect square because it can be written as something squared. This is a perfect square because it can be written as something squared. All right, let's move on. This is an interesting question, and it usually, I wouldn't say stumps students, but they don't get it completely right. And what you see here is a difference
and each of these is a square. So if I needed to, just to convince myself, I could write this as x squared minus y squared. So if I use my rule, the way that this is going to factor is going to be the sum and the difference of those two things which are being squared. Okay. So a lot of students would say, hey, I got it, I saw it, and I'm done. But you're not done, because what you have to understand is, although this is prime, this will factor. And so we have one more step to go. This is x squared plus y squared. But x squared minus y squared, again, is the difference of two squares. X plus y, x minus y. So this is an example of a problem in which you need to factor twice in order to get completely to the end. And remember, this right here is prime. It doesn't factor. Okay? The last little topic in this section is how we factor the sum of two cubes and the difference of two cubes. And I'll just give you the formulas. If we have the sum of two cubes, it factors in this pattern. And if we have the difference of two cubes, it's going to look like this. Okay, and so those are basically just rules for you to remember. And let's look at an example or two. So a very simple example would be to factor x cubed, let's say minus 8. That's the difference of two cubes. It's x cubed minus 2 cubed. So if we use our second rule, it's going to be x minus 2 times x squared plus 2x plus 4. See how that works? Let's try one more. Let's see if I can fit it in here. We want to factor 54x cubed plus 250 y to the sixth. So we take out a common factor, don't forget that, which is going to be 2 times 27x cubed plus 125 y to the sixth. And that's going to be 2 times, okay, the first thing is 3x cubed plus 5y squared cubed. See that? Y squared cubed, you multiply and you get y to the sixth. And so this is going to equal the 2 times 3x plus, right, using the rule, the top rule, 5y squared. Okay, get a little tight. 9x squared minus 15xy squared, oh, I think I can make it, plus 25y to the fourth. Whew, made it. So I was just using the top rule up here, and you should be able to see how a is 3x and b is 5y squared. So a plus b, this is a squared, this is minus a times b, and this is b squared. Alright, so there we go, we're done with that section. Moving right along. See you next time. Have a good day.